All right, let's pull back the curtain on Node.js. It's the invisible engine that powers so many of the apps you use every single day. We're going to dive into what it is, exactly how it works, and why its creation was, no joke, a complete game changer for the web.
So you got to ask the question, right? How on earth did JavaScript, a language that was literally built just to make web pages a little more interactive, how did it escape the browser and end up running these massive, data-heavy apps for giants like Netflix and Uber? The answer, in 2 words, is Node.js.
And here's the first thing you really need to get. Node.js isn't a new programming language. It's what's called a runtime environment. Just think of it like a special playground that lets JavaScript run free. It takes Google's unbelievably fast V8 engine, yep, the same one from the Chrome browser, and lets you run JavaScript code directly on a server, totally outside of a web browser. And that was a revolutionary idea.
But what really makes it so special? I mean, it's not just about using JavaScript on the backend. The real magic, the secret sauce, is in how it handles work. And its weapon of choice is something called a non-blocking I/O model.
Okay, check this out. A traditional server is kind of like a single-lane drive-through. It takes one order, it makes that entire order, hands it out the window, and only then does it even look at the next car. If someone orders food for their entire office, guess what? Everybody else is stuck waiting. That's blocking. Node.js, on the other hand, is like a modern restaurant that gives you one of those buzzing pagers. You place your order, and instead of just standing there, you can go sit down, check your phone, whatever. The server is already taking the next person's order. When your food's ready, your buzzer goes off. The server never, ever stops just to wait.
So what's the engine that makes this whole buzzer system work? It's something called the event loop. You can picture it as this tireless manager who just never stops. It's constantly asking one simple question. Is my main worker free right now? If the answer is yes, it glances over at a waiting list of finished tasks, those are our food orders, grabs the next one that's ready, and hands it off to be processed. By never waiting and always checking for the next finished job, a single Node.js thread can juggle thousands of connections at once. It's incredibly efficient.
Under the hood, there are really 2 main parts making this all happen. We already mentioned the V8 engine. That's the high-performance brain that compiles JavaScript into machine code at crazy speeds. But the other piece is a library called libv, and it's the real unsung hero here. If V8 is the brain, libv is the brawn. It's the part that actually handles all these slow, boring stuff like reading a file or waiting on the network, so that the main V8 engine never has to wait around. It just gets a notification when the work is done.
Of course, all this asynchronous power comes with a challenge. You know, when you're not doing things in a simple step-by-step order, how do you keep your code from becoming a complete and total mess? And this is exactly what developers ran into early on. To handle a task when it was done, you'd give it a function called a callback. But then if you needed to do another async task right after that one, you'd have to nest another callback inside the first one, and then another and another. This leads to this infamous thing called callback hell, or what some people call the pyramid of doom, where your code just keeps indenting further and further to the right until it's almost impossible to read or fix.
Thankfully, the community came up with some much better ways to handle this. First, we got promises, which let you chain your asynchronous steps in this clean, linear way. And then we got async await, which is basically just a beautiful way of writing promises. It lets you write code that handles all this asynchronous stuff, but it looks and reads just like simple top-to-bottom code. It completely slayed that pyramid of doom.
So beyond its core architecture, the other thing that makes Node.js so powerful is its absolutely incredible ecosystem. The whole philosophy is you almost never have to build anything from scratch, and at the heart of that whole ecosystem is NPM, the Node Package Manager. It's 2 things, a gigantic online library of free, reusable code modules, and a tool you use on your computer to easily install them. You need to handle dates, build a web server, connect to a database? You can bet there's a package for that. Probably hundreds of them, actually.
And pretty much every Node.js project you'll ever see has this one file, package.json. It's basically the project's ID card. It lists all the external packages your project needs to run, its dependencies, and it lets you define helpful little command line scripts. It's the central blueprint for the whole application.
Okay, so we've got the core ideas, we've got this amazing ecosystem of tools. So now, how do developers actually put all these pieces together to build powerful services that can scale up to handle millions of users?
Well, you don't start from an empty file. You use a framework. And in the world of Node.js, the undisputed king is Express.js. It's this minimal, super flexible framework that gives you everything you need to start building a web application, defining your API routes, handling requests and responses. It's the backbone of countless apps out there.
But this brings up a really good question. You might be thinking, hold on a minute. If this famous event loop runs on a single thread, how can it possibly take advantage of my modern computer that has, 8, 12, 16 cores? Is all that extra power just going to waste?
No way. The built-in solution is called the cluster module. It lets you create multiple copies or worker processes of your application. There's a main master process that acts like a traffic cop, receiving all the incoming requests and then distributing them to the worker processes, each one happily running on its own core. This is how a single Node app can soak up every last bit of a server's CPU power.
So what about something really heavy, like processing a huge video file? That's not waiting for a network, that's pure CPU work, and it would block the event loop. Well, for that, Node can just hand off the job to a completely separate child process, and it has different tools for this depending on what you need. You might use one called spawn for a long-running task that's constantly sending back data, or another one called exec for a quick command that just gives you a single result when it's done. The key is the main application stays fast and responsive no matter what.
So there you have it. Node.js took JavaScript from being a simple browser language to a powerhouse on the server, all thanks to its non-blocking model and a massive, passionate community. It really proved that speed isn't just about raw horsepower, it's about being smart and efficient. And that leaves us with a really interesting question. Now that JavaScript has conquered the server, what's its next frontier? What new problems is this unique architecture going to solve next?